Hello there. In this video, I am going to explain wind power or wind energy, the basics and some calculations. You can see different wind turbines depending on the size and type. We will try to understand what they are. They produce electricity from kilowatt range to megawatt range. Kinetic energy is defined as half mv squared. When air is moving, that is kinetic energy of wind. To extract the energy, we use wind turbines. So these wind turbines have blades. Alright, wind energy is a clean source of energy and it is free and readily available as a renewable energy source. Wind turbines allow us to harness the kinetic energy of wind and turn it into electricity. You can see this equation. This is the turbine power. You saw one turbine. So the turbine power or turbine output will be 1 over 8 Cp phi rho d to the power 2 v to the power 3. So what is Cp? Cp is the power coefficient and rho is the density of air, d is the rotor diameter and v is the wind velocity. So finally, when you put all these parameters in SI units, you will get the power output in watts. So this is for a typical horizontal axis wind turbine. I will explain later. Power output from the generator as electrical energy. So the first part here you saw in the previous equation, 5 over 8 rho v to the power 3 d to the power 2 Cp. When you put your generator in the system, there is an efficiency component coming. So generator efficiency is here, and then the gearbox or transmission efficiency, so there is another efficiency coming into the picture. So finally your electrical power in watts will be with this equation, and once you get the mechanical energy or kinetic energy from the wind, finally it will be converted to the electrical energy or electrical power as in this equation. There are two types of wind turbines. The first one, horizontal axis wind turbine. Wind turbines that have horizontal shaft of rotation like x-axis here. And number two, vertical axis wind turbines. Wind turbines that have vertical shaft of rotation like y-axis here. So let's have a look on these two turbines. The first one, vertical axis wind turbine. The second one, horizontal axis wind turbine. Right. The next one, the components of a wind turbine. You can see the blades first. There are 3 blades that is connected to the low speed shaft here, the light green color one, and it is running typically at 10 to 20 rpm. Then there's a gearbox here to increase the rpm to 1000 or above. This is to rotate the generator, and to get the electricity it needs high rpm. If you want to stop the machine, you have a brake system here. There is another type called direct drive systems. So these type of wind turbines, they don't have the gearbox, the middle part here. Let's do a typical calculation to compute the power with an example. Part A, what is the output power of the wind turbine or wind power generator if it has the following parameters? You are given blade length, power coefficient, wind velocity, air density, gear efficiency, generator efficiency. And part B, what is the blade tip speed if rotor has 20 rpm? So let's try to understand what they are. So blade length is this one. So when you see the blade length, immediately you imagine that there is a circle here, and that gives you the diameter as 102, and the wind velocity, that is 10.5 meters per second, coming and hitting and turning the blades. And you are given the air density, gear efficiency and generator efficiency. So with the equation what I explained before, the power output, you need these parameters: to the rho, the density of air 1.22, and the wind velocity, that is given as 10.5. You have to use 10.5 to the power 3. And remember, this is the diameter, not the blade length. So the diameter is 102, and power coefficient, that is 0.45, and these two efficiencies, generator efficiency, that is 91%, and gearbox efficiency, that is 88%. So once you put all these values, your final answer will be coming in watts. So it's a large number, so you can convert it to kilowatts, dividing by 1000, or you divide by another 1000, you will end up with 2.1 megawatts. Right. The next part, part B, what is the blade tip speed if the rotor has 20 rpm? You can see this is 20 rpm, this is turning the blades at 20 rpm, and blade tip speed. So you see one blade here, you have 3 blades. So the blade tip speed means the end speed of the blade, right? So you have omega, we call this omega r, or blade tip speed, that is 5d rpm over 60. So you have 5 and your diameter is same 102, and the rpm is given as 20, so you will end up with 106.8 meters per second. That's the speed here. Now you can see a wind farm. There are some disadvantages of wind power. Power output is varying according to the wind speed. That's not uniform all the time. These wind farms can have an impact on the ecological system, some noise. However, this wind energy produces a clean and sustainable energy. Thank you for watching.